Daqshekk minn għandi għalissa jiena ħanersaq lejn is-salott tagħna biex niltaqgħu mal-ewwel mistiedna tiegħi, Anastasia Seifert, li għal raġuni ta' din l-intervisti ħanaqleb ftit bl-Ingliż ħabba li Anastasia mhijiex Maltija. Hello, Anastasia, how are you?
Nice, I'm good. How are you?
Lovely to have you here. I'm good.
Yes.
And now the program started, so now we start relaxing into it and meeting all the guests. So it's lovely to have you here.
Thank
and
you
in fact,
so much.
I'm going to start with, you're a female scientist,
Yes.
correct?
Yes.
And your research is?
In fast radio bursts.
Fast radio bursts. What are fast radio bursts?
So fast radio bursts are basically these bright pulses of radio emission that occur on millisecond timescales. And they're very spontaneous, so we have no idea where they come from, but we do understand that they're a phenomenon that's happening.
Wow, so literally a radio wave, along the same lines as our radio waves, like the ones we actually listen to and all, but they're much smaller.
So we actually go above that as well. So the radio spectrum, this can go beyond what we receive in telecommunications, radio, TV. So this is a wide array of radio frequencies.
So basically all our communication, radio, television, mobiles, they're all radio waves.
Yes, yes.
Different lengths.
Exactly.
But you're actually trying to measure these fast bursts, they just appear out of nowhere.
Exactly, exactly. So they were first discovered in 2007, and they appeared in this pulsar survey. Pulsars are also radio objects. They're very similar to fast radio bursts, except we can identify where they're coming from. So these come from neutron stars, and these are basically stars at the end of its life cycle. And these are highly magnetized and highly rotating, so they tend to emit radio waves at their poles. And this is what we receive on Earth.
Wow, I'm going to translate this
for
our audience. Bażikament li qed tgħidilna Anastasia hija li bażikament aħna għandna spettru ta' radio waves sewwa ta' mewġ tar-radju li aħna nisimgħu. Ir-radju mhux biss li nisimgħu jew li naraw televiżjoni u jew li nċemplu permezz taċ-ċellulari. Għandna spettru b'diversi isien differenti ta' mewġ. Issa, x-xogħol ta' Anastasia fl-Università ta' Malta hija li taqra dawn ir-radio waves jgħidulhom li jiġu mill-ispazju u dawn ikunu verament tul qasir ta' żmien u verament maġlin, allura ma jafux minn fejn ġejjin u ġew skoperti fl-2007. Ħafna drabi jkunu kapaċi ġejjin minn neutron star, bażikament stilla li waslet fit-tmiem ta' ħajjitha, mhux l-istilla tagħna, ġifier mhux ix-xemx tagħna, ix-xemx tagħna stilla wkoll għax Alla ħares tispiċċa dik fit-tmiem ta' ħajjitha għax ankella aħna ma nibqgħux hawn. Anastasia, what are we seeing on screen?
So what we're seeing, if you look in the red box, there is a bright pulse that is curved. So that is an FRB. And this is very interesting because as compared to pulsars, pulsars also have a curvature, but slightly less. Now this curvature comes from the light traveling through something called the interstellar medium, and this is filled with lots of gas and dust particles. Now typically the light should be horizontal completely, but the problem is as it's interacting with this dust and gas particles, it's actually slowing down the light by a little bit, so there's a delay.
So that's why it bends.
Exactly.
Wow. Do you ever think, so you know, maybe some people out there are asking as well, do you ever think, to consider that this could not only be natural, but in the same way we create our radio waves to communicate? Yes. Maybe there's a higher intelligence out in the universe,
exactly.
And this is what's left out of their communication?
Yes, so that is actually something that is speculated just because we don't really know too much about these objects. We still don't know where they're coming from. Like pulsars, we know they're coming from neutron stars. But because there's so much information that we still need to understand, most of the speculation does go to alien communications, which is a little funny to kind of speculate, but it is out there.
We're getting there, you know, like we're realizing, because sometimes when you watch these sci-fi movies, you realize that even our technology within the world, we're kind of going holograms and speaking to screens. I mean, in the 70s and 80s when Star Wars came out, it was something we couldn't comprehend. Now it's actually happening.
Yes.
So who knows? And so FRBs, the fast radio bursts, are fairly recent because they were discovered in 2007.
Exactly, yes.
And basically 15 years ago. what's your research like within the University of Malta? What happens? What do you do?
Yes, so basically what we try to do is look at these radio surveys. So these surveys are taken from radio telescopes, and they basically survey the sky. And what we try to do is try to look through this data and see if we find any signals that are coming through. So what we also try to do is mitigate or try to reduce on the noise. So like we were talking about the cell phone communications, military, that can affect our observations. And actually it can mask the noise so that's coming through. So that's actually a bit of a problem that we're trying to work on. So that's why we try to aim for the higher frequencies of radio
I'm going
waves.
to translate this as
Sure.
well. So basic, and we are mentioning noise. Noise, it's not the auditory noise that we can hear, it's
Exactly.
all the other sounds.
Exactly. Think of like the static on the TV.
Exactly, you're
That's
trying
what
to
that is.
remove that. So ħan introduċi ftit għax fliqet tajt Anastasia verament interessanti. Bażikament l-irwol tagħhom fl-Università ta' Malta hija li aħna permezz ta' radio telescopes qed nieħdu ħafna informazzjoni mill-univers għax bażikament l-univers mhux qed jitfa' biss id-dija tal-istilel, ma qed jitfa' wkoll raġġi tar-radju. Sewwa, issa permezz ta' radio telescope huma jaqraw dawn ir-raġġi u qegħdin jaraw din id-data kollha. Jekk hemmx affarijiet simili, affarijiet differenti, biex bekk jippruvaw jifhmu minn fejn ġejja x'qed jikkawża. Ovvjament l-ikbar sfida li għandhom hija li ovvjament kif għadna mhux biss l-univers qed jatfa' dawn ir-raġġi, imma wkoll il-mobile tiegħi, il-mobile tiegħek, il-komunikazzjoni, s-satelliti tagħna l-għur nippruvaw jagħmlu hija li neħħu dan in-noise, dan l-istorbju, mhux storbju li nisimgħu tal-udit, imma storbju bħal meta qed tipprova titkellem, hemm ħafna storbju qed tipprova tifhem il-vuċi. Huma jagħmlu l-istess b'dawn il-mewġ dawn ir-raġġi biex bekk jaraw daqsxejn żgħira x'qed jiġri. I've been told we have 2 minutes to conclude, so so basically we've mentioned the noise, we mentioned the radio telescopes. So where are we off to? So any predictions, any theories that we wish to kind of prove, or where is this new research headed?
So basically what we want to do is we want to explore really where they're coming from, if we can identify a source, the emission mechanisms behind it. So what we want to do is look at future telescopes such as the SKA. It's the Square Kilometer Array. And this is a next generation telescope, and this has higher resolution, higher bandwidth. So this will allow us to really view the sky in areas that we haven't seen before, and also do this at a very, very small time scale so that we can record very, very quick events.
Wow, and when you're seeing areas of the sky, these are light years away, right?
Yes, yes, yes.
Really far away.
And these are objects that are millions of years old. So, yeah.
And we're still seeing them like in the past, right? Because sound takes longer than light to travel.
Exactly, yeah.
So basically what you're seeing now is what happened light years ago.
Exactly.
Wow, any moments in your research where you're like, wow, I've noticed this, this could, any eureka moments, moments of discovery?
We also work with something called machine learning, where basically we try to have computers analyze these pulses, and having that in itself is something so wonderful to see that technology can do this, not just humans. So.
Wow, and then you compare what technology is finding out and what you are finding out.
Exactly.
It's so interesting because there's so much going on, so much research going on at the university, that it's really, really, really interesting. And were the first FRBs discovered, were you looking for them, or were scientists looking for them, or were they just a random?
They were just random. So we actually didn't, so similar to the gravitational waves that you had talked about, that was something that they theorized. This was something they didn't. So this is something so interesting, and why we want to find out where they're coming from and how they kind of came out to be.
Wow. Anastasia, thank you so much.
Thank you very much.
Thank you so much for that very interesting conversation, and wishing you and your team and all the students, because you have different students as well, undergrads, postgrads also working on the research, the best of luck with all your future endeavors.
Thank you so much.
Thank you so much. I'm going to translate that last bit. Bażikament ikkonkludejna billi ngħidu li dawn ir-raġġi huma dawn xi ħaġa li ma kinux qegħdin jistennew, ġifieri ġimagħtejn ilu jekk tiftakru tkellimna dwar il-mewġ tal-gravità li l-univers jisek għandek il-wiċċ tal-ilma li inti meta jkollok xi ħaġa qed tagħmel mewġa żgħira bħal meta titfa' ċaka fl-ilma. dik konna qegħdin naħsbu fiha fi żmien Einstein. Di xejn. Allura di literalment skoprewha b'ċikka fl-2007 u għalhekk ir-riċerka hija kbira. U għandna nkunu kburin l-Università tagħna tal-pajjiż tagħna hija involuta f'parti minn din ir-riċerka. Mela hawnhekk fisimkom nirringrazzja l-Anastasia, so thank you once again. I'm telling them that I'm thanking you once again. Aħna nifu għal waqfa qasira ta' reklami u nkunu magħkom din id-darba għal eżerċizzju tal-kitba. Jekk tħobbu tikdbu, tixtiequ tippruvaw tikdbu karta u lapes għax ħankun qegħdin nikdbu mal-li llul. Ibqgħu hemm.